My name is Eric Heidinger. I study fire protection engineering at Oklahoma State University, and I'll be presenting you today my senior project. So first we'll take a look at the project as a whole. I performed a failure analysis on a solenoid operated valve which mistakenly tripped, resulting in the unnecessary discharge of halon in the subfloor of the Unit 2 control room of a nuclear power plant in upstate New York. This occurred on May 27th of 2017 during an internship that I had. My task was to figure out why it happened and what we needed to do to keep it from happening again. So an electronic control head is just a valve actuator that controls the release of suppressant in a fire protection system. It can be operated either manually via a switch on the outside of the panel, which is guarded with a pin similar to the pin that's in fire extinguishers, or it can be actuated through an electronic signal sent to it by the fire computer. So first thing we did is we looked at the fire computer and to analyze the signals that were sent by the control panel to the head. The first alarm received, first signal to the computer, was a flow alarm, meaning that there was no signal sent from the control panel to release this halon. We know that the head was not operated manually because there was a tamper seal, and that was still intact, which means it hadn't been operated manually. That leads us to believe that there was some type of mechanical failure on the internals of the component. So the next step was to do an internal inspection of the component, and then we would need to analyze our findings, and after that we could do corrective action and of course post-maintenance testing. So again, this is an electronic control head. This is the actual component that we're looking at here on the right side of the slide. This sits on top of the tank, and it will drop a pin with spring pressure that releases all the halon into the system through piping, and it will be sent to wherever the area is that you're controlling. In this situation, this halon system was hooked up to protect the subfloor of the control room, which is mostly filled with electrical components and wiring. So this is the bank that we were looking at here. There were 15 total control heads. This is the control head here sitting on top of the tank. When it actuates, the halon will flow up through this black tubing into the red piping and then ultimately to the control room. So there are 15 control heads, each corresponding to a main and backup halon tank. They're physically located in the hallway outside of the control room, which they were protecting. The actuation of this valve works in such a way that when the spring is released, it stays open until that entire contents of that tank are discharged, and the tank can equalize with atmospheric pressure. So once it's open, it's going to dump everything in that system. Here's a picture of the control panel, the computer screen, and the signals that it received. They're highlighted in red right here. It's the first signal received, and that's a flow alarm. This came in at 1:20 a.m. So there was no signal sent from the panel to actuate this control head. And again, the tamper seal was still intact. This is all leading us to believe that something failed mechanically inside of the component to release this spring and allow this halon to be dispersed. So there's 15 total units, and 14 of them had bent posts which support the internal latching of the spring. This is the post here. You can see that it's bent away from the spring pawl, allowing it to not be seated as cleanly and requiring less mechanical agitation to be knocked off of there, which would cause the halon to disperse. All of the units with the bent post were manufactured on the same date, October of 1982. The one unit with the unbent post was manufactured in 1985. Now, one theory that was going around was that this constant spring pressure on the unit over 35 years had caused this pin to bow outwards over a long period of time. But this is not supported by the fact that a unit only 3 years newer had no signs of bending whatsoever. Now here's a video of the component actuating. You can see that there are 2 points of contact that keep this spring in place at all times and keep the halon in the tank. Now this pin, being bent the way that it is, allows the spring pawl to more easily slip off and actuate the head. The component that actually moves due to the switch is this bar here, and this is the latching post, which is just barely seated on the bar as well. Here's one more time. So that's how the component works internally. And again, this bar can be moved either manually by the switch like I'm doing here, or by an electronic signal which actuates it. from the control panel. So when that spring releases, this pin pops out. Here this is in the closed state, and then in the open on the right, the spring will punch down into a corresponding pin that sits on top of the halon tank and disperse the entire contents of the tank. So initially what we have before we do any testing, we have a suspected manufacturer defect in the heads manufactured on October of 1982, which could potentially have been worsened by the 35 years of spring pressure, but again this is refuted by the fact that the component from 1985 showed no signs of bending. So all the new heads that we bought to replace them were internally inspected with no indication of the same defect, and they all underwent post-maintenance testing, and they were found to be in satisfactory operating condition. So our recommendations at this point were that all new heads be checked for defect before installation, that they were checked periodically to install no degradation. What we mean by degradation here is the bending of that pin over time due to spring pressure. We're going to go on to do a failure analysis of the failed head to determine what conditions preceded the failure. And in nuclear, you always share your findings with the industry because the #1 priority here is safety. We don't want to have a nuclear release. We don't want to have a release of halon in the control room, which could disturb the operators from doing their job and protecting the public from radioactive release. So this is just going to walk you through the testing process first. First, there was a visual inspection of the components, the notice on the general condition of the units, any abnormalities or defects noted. When I say abnormalities, we had bought a new head, which is assumed to be in pristine condition, and any deviations from the condition of the new head are assumed to be abnormalities due to damage to the head. We performed functional testing, cycled the units to make sure they work, to see if cycling them could cause damage possibly. And we're going to attempt to inadvertently actuate the SOV-123 alpha, which is the actual head from the plant that failed. We're going to try to trip that by performing mechanical agitation. We'll see how we do that later. After testing, we're going to reinspect the component to see if anything has changed, and then we're going to disassemble the part and take a closer look at the unit internals. So this is the actual unit that failed, that resulted in the discharge of the halon in the control room. Now this is extremely important because the control room needs to be manned at all times to maintain the integrity of the reactor vessel. Now the reactors did not evacuate the room, but they were close to. The halon was underneath their feet, and they said it sounded like a jet engine taking off beneath them. And this compromises the integrity of the control room, which compromises the integrity of the plant. They could have scrammed the reactor, which means to shut it down, and the company would have lost a lot of money for that missed runtime and lost production of electricity. 121 Bravo, that's mislabeled. It's in the closed position, as you can see by the fact that the pin is still within the unit. This is the new head. Obviously it's shinier and it is assumed to be in perfect condition. Any deviations from the condition that this head is in are assumed to be damage to the units. Is the unit that actually failed, this unit here. 21 Bravo did not fail, but it shared the same defect. It has the bent pin. Also, there's a screw that's not screwed in. Again, we can't be sure if that happened before we looked at it or not. So here's the internal components. This is shown in the open position. This is the valve that failed. You can tell that because it's not resting on either of the two contact points. That spring has failed and that pin is out. On the left here, these are the electrical components. Not a whole lot to see here, but just note that this is in the open position, which is why it's not resting on either two of these contact points. This is the bent pin again that we believe caused the activation. So here's 121 Bravo. It's shown in the closed position, as you can see by the latching post here on the bar and the spring pawl on the pin. You can see that the bend here is not as significant as in 123 Alpha, but it is present. We'll see some closer pictures of that pin later. Resting on that pin there, and with just light tapping, we were able to get it to slip off, which would result in the discharge of the suppressant in the system. So here's the latching posts, okay, on 123 Alpha, 121 Bravo, and the new unit. You can see how significant it is, how much better seated this post is. Again, just a light mechanical agitation here, or just, it could slip off and cause an unwanted discharge. Here's the latching post again. You can see how it bows outwards. This is the 121 Bravo unit. This is the one with the less severe bend, but it's still evident, and it was like this in every single unit that was produced on October of 1982. Here are the pins removed from the component. You can see the severity of the bend in comparison on 123 Alpha. 121 Bravo is not as severe, and the new unit is perfectly straight, allowing proper seating of that spring pawl and not allowing that pawl to slip off. So our results, we found that the bent latching post combined with the poor seating of the latching arm caused mechanical failure of the component. We're suspecting that this is a manufacturer defect due to the fact that this defect is shared between all of the heads manufactured in October of 1982. It's possible that the bending was exaggerated by the 35 years of spring pressure, but there's no way to be certain of that, and the fact that the head from 1985 showed no signs of bending refutes that argument. So, the mechanical nature of this failure confirmed what was initially expected, since there was no input sent out by the fire control panel to actuate the head, and the electronic internals were proven to be functioning properly. It makes sense that the failure happened within the mechanical internals of the component. The fact that the defect was common among all units that shared the October of 1982 date stamp for manufacturing date indicates that these defects may be due to a flaw in the manufacturing process, such as how the pin was driven in with too much torque and bent, not something that happened over time. There's no way to be certain, but that's what all signs point to. These parts could have been part of a bad batch that were sent out all over the industry. So the industry was notified of this problem, and they were told to contact any vendors that may have purchased this part from them on that date. It's important to stress the severity of this event. You're discharging halon into a control room manned with operators that are charged with controlling the reactor vessel and watching very important things and preventing a nuclear meltdown. If they evacuated the control room, this could have caused something very bad to happen. Worst case scenario, reactor meltdown, but more realistically, a scram of the plant, which would cost the company a lot of money from the lost productivity time. That pretty much sums up our findings. Again, we believe that the components failed mechanically due to the bent latching post. And that wraps up my presentation. Thank you.